Hi, this is the next video covering problems 8E through problem 9 on the test review. So for this function here, we actually have a quartic polynomial function, degree 4, so we should end up with 4 solutions. If you take a look at it, it is factorable, but let's go ahead and take a look, because sometimes you might not notice right away that it's factorable. If it is, I want you to do it that way though. Oops, x to the 4th. Minus 2x squared minus 63. Let me change my viewing window here. So it appears to be crossing at positive 3 and negative 3. So we can verify it on our table. There's 3, 0. So we're good to go there. And negative 3, 0. So we're good to go. Alright, so we know that for these solutions, one of them is 3 and one is negative 3. I am going to do this by factoring, but I'm going to show you the other way using division so that you'll be able to review that as well. So when you see this one here, note that it's going to be factorable as a quadratic, similar to problem, let's see, number 8b. So we can, if we can think of factors of 63 that combine to give us negative 2, plus we have the fact that the second coefficient's or second term's degree is half that of the first, we should be good to go here. So we can use 9 and 7 to get 2. So I'm going to start off here with x squared. Because this is negative, I know one's negative and one's positive. To multiply and get a 63, and I would need negative 9 and positive 7 to get those zeros, those factors. Let's see. So if we set x squared minus 9 equal to 0 and x squared plus 7 equal to 0 and solve each of those, that is you can factor that again if you wanted to though. Then x is positive or negative 3. Like I said, this is a difference of squares, so you could have recognized that this was x minus 3 and x plus 3. Hence, the positive and negative 3. If you subtract 7, then take the square root of both sides. 7 is a prime number. We can't simplify that any further. However, it is negative, so we can make that I square roots of 7. So our solutions should be 3, negative 3, and I, oops, sorry, I forgot my plus or minus. I square roots of 7 and negative I square roots of 7. So if for some reason, like I just almost made the mistake of only putting the positive, your check is to make sure that if it's degree 4 that you have 4 solutions listed, and that might help you catch a mistake like that. So let's say you're not very good at factoring and you want to, but you graphed it and you found that 3 and negative 3 were solutions. So what you could do is synthetic division. So if we put 3 in our box and write out the coefficients and constants, being sure to add in zeros for any missing terms, we would have 0 for our cubic term that's missing, negative 2, 0 for our missing linear term, and then negative 63. So I'm going to just go through this fast. Oops. 21, positive 63, 0. So we actually have a quartic. I'm just going to rewrite it again so it'll be clear. But then we just take it and do division again with the negative 3. And we get x squared plus 7. So then again, we set that equal to 0 and solve it, and it would work the same way we did up here. Subtracting 7, take the square root of both sides, and getting positive and negative I square roots of 7. So you can do it that way. 3, negative 3, and I squared root of 7, and negative I squared root of 7. Two different methods to get the same result. Alright, now moving on to the next one, called G. Don't ask why I forgot the F. F of x equals 4x to the 4th minus 32x. When we take a look at this one, it is quartic, which means we should end up with 4 solutions again. Notice that both of these terms have a common factor of 4 and x. So I'm going to factor out 4x. leaving me with x cubed minus 8. At this point, we should recognize this as a difference of cubes. We've talked plenty about that. Remember, we take the cube root of the first term and cube root of the second. Our sign pattern should be minus plus plus, and then we square, multiply, square. So we've got the factors 4x, x minus 2, and x squared plus 2x minus 4. Now, if you're not very good with all that factoring, again, remember on the last problem I showed you what you could do. So I'm going to type in here 4x squared, minus 32x, so we can have an idea of what we should be getting. Looks like we've got just 2 real. So let's see. That should make sense. We've got 4x equals 0, x minus 2 equals 0, and x squared plus 2x plus 4 equal to 0. So this one here, we're going to get 0, 2, and we've got a quadratic. Now, we already saw that it crossed the graph at 0, and let's see. Uh, 42. Oh, I apologize. I was just thinking it didn't cross at 2 earlier. I mistakenly put squared instead of the 4th power, so that should be 4x to the 4th minus 32x. So it crosses here at 0 and at 2. So 0 and 2, that tells us our other 2 should be complex, so we need to use the quadratic formula. And so we've got x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all over 2a. So we'll have negative 2 plus or minus. That's 4 minus 16, and 4 minus 16 would give us negative 12. Let's see. So at this point, we can simplify this. If we're simplifying square root of negative 12, we can put I out front and break that down into factors of 4 and 3, of which 4 is a perfect square, so that would give us 2i square roots of 3. So we should end up with 2i square roots of 3 here all over 2. But remember, if these numbers out here can be simplified by a common factor, we must do so. So all of these are divisible by 2, so we should end up with negative 1 plus or minus 1i square roots of 3. So now I have all my solutions. 0, 2, we've got negative 1 plus I square roots of 3, and negative 1 minus I square roots of 3. So just make sure you have all 4 listed. Okay? And next, we'll move on to H. H was an interesting one. It's actually a 7th degree polynomial. So we should end up with 7 solutions. Let's see what happens. So we've got 1, 2, 3, 4 terms. The first thing I notice when looking at this is they all do have x in them. So we could look for a GCF of x to the 4th power. Let's go ahead and graph it, however, to go ahead and see what this thing should be looking like. Or how many solutions and what kind we might have. Alright, so when I graph it, one, and it looks like we've got a multiplicity of 2 here, and then it goes back up. Alright, and the end crosses. So if we look at H, let's first go ahead and think about taking out our GCF. So we've got a multiplicity going on. We know that because it touches and bounces off that axis that it's an even multiplicity, and not necessarily 2. So keep that in mind. So let's go ahead and look at what we can do in terms of factoring. If we look, all of them have at least x to the 4th in them. So I'm going to factor that out first. And that tells us there if we set that equal to 0, and we would take the fourth root of both sides, that we would still get 0, but we would have multiplicity 4. So that actually takes care of 4 of our solutions. Notice that the graph also appeared to cross at positive 2. Let's verify that on our graph, our table rather. So 2, 0 is on there, so that means it does cross at 2. So I know that I have 0 multiplicity 4. That 2 is a 0, so now that's 5 solutions, and I need the other 2. So what I'm going to do is take this 2, and I'm going to do division, but of only this cubic polynomial factor. Okay? I'm going to take this cubic factor and do this. I wouldn't want to do this to the x to the fourth because we can already establish what the zeros of that factor are. We want to find what are the factors of this 0. So, let's see. What we'll do now is divide with that using these coefficients, 2, 5, 3, and negative 42. And we get 2x squared plus 9x plus 21. So we have a depressed quadratic polynomial that we can now set equal to 0 and get the last two that are complex. Remember, we have four zeros, 5, and we need 2 more. So this is going to give us our 2 complex zeros. So I'm going to use your quadratic formula, letting a equal 2, b equaling 9, and c being 21, and substitute. So x equals the opposite of b, plus or minus the square root of b squared, minus 4 times a times c, all over 2a. So notice I always fill that in, but then go and find the discriminant. So not using my radical, I'm just going to go to my home screen and type this in. Oops. 9 squared minus 4 times 2 times 21. And we get negative 87. From here we want to simplify. Now 87 we don't know of any common or any factors probably offhand, but it's odd, so I'm going to try 3. It is divisible by 3, we get 29, but 29 is a prime number, so because its only factors are 3, 29, 1, and 87, we know we can't simplify any further. So we're just going to have negative 9 plus or minus. The most we can do is pull out I. Okay? So again, we have 4 zeros, 5. We've got negative 9 plus I square roots of 87 over 4. And negative 9 minus I square roots of 87 over 4. And that's all 5 of your solutions. It is totally fine to leave this looking just like this. You do not have to separate it. I did this to show you that this is these do make up 2 separate solutions there. All right, and that takes care of all the solving. So next I'm going to talk about number 9. I'm sure you've already read through 9, so the first thing I'm going to do is type it in our calculator. So x cubed plus, negative 2x cubed plus 6x squared minus 8x plus 8. So this is supposed to be modeling the amount of any drug that's left in a patient's bloodstream over time. So if we take a look at our function, we've got a cubic function. One thing that's always very important to recognize is that for application problems, we're really only talking about quadrant 1. So if you kind of ignore quadrants 2, 3, and 4 and just focus on quadrant 1, we can see that we actually only have one real 0. So if you can think about this representing the initial amount in your bloodstream, the y-intercept being the constant term. So going back here, if this is your constant term, the 0.08 is on that graph. So imagine having about 8 milligrams of a particular prescription drug in your system, and then over time it dwindles, and eventually it's there's none left. But so we're really only concentrating here on this quadrant. So A says find out how many hours after administration will the drug be totally eliminated from the bloodstream. So if this is time, what we can assume is that after 2 hours, T is represented in hours, after 2 hours there's nothing left. And we can look at our table to tell us that, 2, 0. So for 9A, you would want to say P of 2 equals 0. So after 2 hours, the drug is eliminated. Then it says identify and discuss the other routes. So what we really want you to get out of this is understanding that because this function is cubic, we can tell from the graph that we have 1 real and 2 complex. So the only one that's relevant is the real one. So if it says identify and discuss the other 2 routes, you do need to identify them, but what's going to happen is they're not relevant. So I'm going to go through now the process of being able to identify those routes. So because we know our solution here is 2, we're going to use 2 and then use synthetic division. And we get negative 2 t squared plus 2t minus 4. If we set that equal to 0 and use the quadratic formula, but of course you could use completing the square to do this also. What I am going to do though, however, is when solving, we can always divide out our a term. It does make it a whole lot easier. We can just solve that. If you want to do that by completing the square, you go ahead, but I'm going to use quadratic formula. So we get x equals the opposite of b plus or minus the square root of b squared minus 4 times a times c all over 2a. So notice how saying the formula over and over helps me to plug it in quick. It might help you as well. So on my home screen, negative 1 squared minus 4 times 1 times 2. I get negative 7. Right there you can see where I plugged it in. Negative 7, so that's my discriminant. So I get 1 plus or minus I square roots of 7 over 2. So that means for 9b, I'd want you to say, and we'll put up here t. T equals 1 plus or minus I square roots of 7 over 2. However, it is irrelevant. These solutions are irrelevant. Oops, sorry about that. All right, so hopefully those videos help, guys. Good luck on your test.